Yes.
Hello, Mr. Stesh. Welcome on YourPedia platform, and let's start your thermodynamic snap. Achha,
Yes.
my first question is to you: what is the difference between basic and advanced thermodynamics?
Sir, in basic thermodynamics, we learn about the first, second, third laws, and whatever basic terms are there, like internal energy, enthalpy, and its application. In advanced thermodynamics, it is the application of these all formulas or whatever concepts we learn. So
your
like,
highest qualification is B.Tech or M.Tech?
B.Tech.
B.Tech in mechanical engineering or chemical?
Yes. Mechanical.
Mechanical. Achha, you heard about statistical thermodynamics and classical thermodynamics?
Sir, I am aware of the terms.
Can you explain some brief about these terms?
No, sir, actually, sure about the difference.
You heard about continuum concept. What is continuum?
So it is the the continuum concept assumes that the matter, the system on which we are working on, so it is assumed to be larger than the characteristic length what we are considering. So that means there are no voids present in whatever system we are considering.
So why there is a need to consider this concept?
So whatever thermodynamics we study, we are using a macroscopic approach. So for that, whatever minimum size of system what we are considering should be larger than the distance between two molecules, so that the properties what we are defining are remaining constant or which are definable.
Shrish, what is a reversible process?
So it is a hypothetical concept in which whatever path we are following for a given process can be reversed in the exactly same direction without affecting the system and surrounding.
So what causes irreversibility in a process, and how we can minimize those irreversibilities?
Sorry, sir. Start. Could you pardon?
What causes irreversibility in a particular process? Okay, and how we can avoid those irreversibilities? Okay,
so a few of the factors are friction. Friction is one of the factors which causes irreversibility. Then heat transfer through finite temperature difference. Then sudden expansion or free expansion. So these are the major factors we consider in thermodynamics. And to reduce these, like for considering friction, so we use lubrication techniques to reduce the friction. Then for heat transfer to finite differences, so to make it more and more reversible, so we keep the difference between heat transfer bodies as small as possible. And another is free expansion. So it is a irreversible process.
Because superheating in a boiler, okay, decreases the irreversibility in boiler.
Okay.
So can you explain how actually superheating results in decrease in irreversibility? Because due to that reduction in irreversibility only, we are getting the enhancement, increase in efficiency. Just I'm asking you how actually it reduces the irreversibility. Actually, you answered about that, but I want some brief explanation.
Okay. So is it regarding the quality of energy? Because at high temperature, the quality of energy is high. So we can extract.
Why the quality is high at high temperature? At high temperature, entropy will be high or low?
It will be high actually, but
so my second question to you answered actually, but again you need to give me some explanation. At high temperature, entropy is high.
Yes.
At the same time, we say at high temperature the quality of heat is high.
Yes, yes.
So how you see actually these two things?
So if a body is at a very high temperature and if that heat is not utilized, then the lost in work is more. So in that sense, the entropy high will be considered.
And what do you understand by
that
quality? How quality is high? What do you mean by quality?
Means the work potential what it possesses at high temperature is more work can be obtained when we get that system from high temperature to our dead state. Yes, but if that energy is not utilized, then it causes maximum irreversibility.
Fine. Now, fine. You want to answer the first question, the question related to the superheating, or you want to skip that?
Give me a second, sir. I'll just right. Superheating. No, sir, we can continue.
Fine. What is second law of thermodynamics?
Second law gives us the idea about destruction of quality of energy, destruction of quality of energy. So it gives us the idea about the entropy that is forming in a system and how heat cannot be completely converted into work. And also it is given by
destruction.
Sorry, sir.
What is exergy destruction?
So it is the exergy destruction. It is the irreversibilities which are formed in the system. Irreversibilities which are formed which cannot be utilized for obtaining work. So it is given by T naught into S generation.
Good. So you heard about exergetic efficiency also. Exergetic efficiency, which is also known as second law efficiency.
Second law. Yes, sir.
What is that?
So it is defined as the whatever useful work we can obtain or whatever actual work we can obtain from a device to the maximum reversible work which can be obtained from that device.
So this is a general definition of this exergetic efficiency, or this is a definition of exergetic efficiency for work producing devices?
No, for a work consuming devices actually reverse, like W reversible upon W actual. It can also be given in terms of efficiencies, like actual efficiency of the body to Carnot efficiency of that particular system.
Fine.
So it means it tells us that we should not compare with 100%. We should compare with whatever maximum we can attain.
Just suppose you are having a glass full of water. Okay. So tell me how you are going to define its entropy. Okay. Suppose it is at some temperature, 60 degrees Celsius. Okay. Which is higher than the atmospheric temperature.
Okay. Yes.
Atmospheric temperature is 30 degrees Celsius. Fine.
Yes.
So tell me the process, how you're going to define its internal energy. Okay. Entropy and available energy.
Okay. Okay, sir. So the water is at 60 degree. So whatever heat content the water is containing in the glass is given by Q equal to MC delta T. Since water is a incompressible, so C will be Cp equal to Cv, and MC delta T will be given giving the heat value. And since no work is present here, so delta U, that is change in internal energy, will be equal to the heat content of the body. So it will also be given by MC delta T. Coming to entropy, so change in entropy can be calculated by assuming an arbitrary reference point, which can be 0 degrees Celsius in this case, and we can calculate the entropy change. available energy.
Suppose we want to utilize the steam table. Okay.
Okay.
Because you cannot use ideal gas formulations.
Yes.
Like the formulas which we are having to find out the entropy change for ideal
Yes.
gas, those we cannot apply here. So
Yeah,
we are interested in using the steam table. Okay.
yes.
So which particular table you will refer? How you will utilize the steam table?
So steam table gives us
the condition of the water is what? The water at 60 degrees Celsius in a glass full of water. That is a subcooled water or some wet liquid or is a superheated substance.
So it is a subcooled water.
Subcooled water.
Yes.
Yes. So which particular table you will refer?
So we'll
If you
refer
open the
our.
steam table, you will find different tables there.
Yes. So based on so steam table are like defined on temperature and pressure scale. So we will be using temperature table, and we will refer SF value for that given temperature. That is so entropy of fluid.
What is entropy, Shreyash? What is entropy? What is the significance of entropy in thermodynamics?
So entropy gives us the measure of disorder randomness that is present in the system. So it is associated with only heat transfer. Also, it gives us how much amount of I mean, it gives us the limitation to how much amount of heat it can be converted into work. So it quantifies that.
Okay. What is enthalpy?
Enthalpy is the energy possessed by a flowing fluid. So along with internal energy, flowing fluid possesses flow energy. So the summation of those two energies gives us the enthalpy.
What is that flow energy, Shreyash?
So the energy which is used to push the liquid or fluid forward. So one layer of fluid gives us energy to push the given amount of fluid. So that energy is given by PV.
Okay. Can you write the energy balance equation for a unsteady flow process?
Unsteady flow process, yes, sir. Yes, sir. So it will be given by m dot h1 in. I'm telling you about the initial condition. So m dot h1 plus kinetic plus potential energy initially, and the heat transfer to the fluid, that is q dot, which is equal to du by dt. That is change in internal energy of that flowing fluid plus enthalpy, kinetic energy, potential energy in the second stage, plus the work done in the flow.
So why du by dt? Why not de by dt?
Internal energy is changing. By dt. So dE by dt will comprise of internal energy plus this potential kinetic energy.
Means you are neglecting the changes in kinetic and potential energies.
Actually, I took them out of the d by dt.
Suresh, can you write the TDS equations? Very famous TDS equations.
Yes, sir. TDS is equals to du plus PdV, and TdS is equals to dH minus VdP.
Actually, when we obtain these equations, we assume a process as a reversible process.
Yes.
But we say that these equations are applicable to any process,
Yes.
whether it is reversible or irreversible. So how we can say that?
So because these equations contain only properties, relations for properties. That is the reason we can use for both.
So then why actually that's fine, like you are saying all terms are representing properties, that's fine. Then how it is actually making the equations applicable for both reversible and irreversible?
So for reversible and irreversible, if end states are same, then whatever we calculate from these equations will be similar for both. That is why these are applicable for both systems, reversible and irreversible.
My last question is to you: what is Mollier chart?
Mollier chart is the enthalpy versus entropy charts.
What is the significance of that?
So its significance. Just a second. No, sir, I'm not aware of the significance.
On Mollier chart, if you draw the constant pressure line, they start actually diverging. They diverge in the superheated region.
Yes.
Why constant pressure lines diverge in the superheated region?
In the superheated region, right? Or in the within the dome?
Can you locate those lines? Constant pressure lines on HS diagram.
So where did you ask? Means outside the dome or inside the dome?
Where is the superheated region?
Outside the dome. Okay. I did not hear. Yes, sir. No, sir. I don't. Yes, sir.
Overall, it's looking fine. You are looking.
So your voice is.
Now it's fine. Shush.
Yes. Yes, sir.
So overall, it was fine. Shush. Most of the question you answered. You are looking comfortable. Not such issue, because this is your first snap. Overall, you are looking sincere. You are looking comfortable, and it's looking like you are trying answering each and every question. Okay. Yes, so sir. There is no issue if you are even unable to answer 1-2 questions. There is no big issue. Okay. But you need to keep trying. You need to try. You need to. It must look like yes, you really want to answer that question. If you face difficulty and if you are not sure about your answer, then yes, you can skip and you can say that, sir, I will study. I will go through more detail about that process. This time I'm unable to recall. Okay. Yes, sir. So 2-3 areas which further you need to cover, like the basic things like statistical, classical thermodynamics things. Okay. What is that advanced thermodynamics? What is continuum concept? Those things you actually missed. Okay, interviewer can start with these kind of questions like what is control mass? What is control volume? What is the difference between CV and CM? Okay, where actually we go with the control mass approach? Where we go with control volume approach? Like these kind of basic questions. Okay, what is reversible process? What causes irreversibility? All those things you answered comfortably.
Yes, sir.
So superheating, actually, superheating, when we carry out superheating, actually you mentioned also at one point ki superheating results in increase in mean temperature of heat addition. Okay.
Okay.
And as the mean temperature of heat addition is increasing, the finite temperature difference between the flue gases and the water is decreasing. Okay. And that decrease in finite temperature between the source means what? Flue gases. Okay. And where we are adding heat? We are adding heat in the water. So when that mean temperature, when that temperature difference between the flue gases and water is decreasing, that is actually reducing the irreversibility. Fine.
Okay. Yes.
And that actually we always will try to do. Like the lesser will be the finite temperature, the temperature difference between the source and the body where we are adding heat, the lesser will be the irreversibility. More is the temperature difference, more will be the irreversibility.
Yes.
Fine. Yes, with the increase in temperature, entropy increases, but at the same time, as the temperature increases, the irreversibility, or what you can say, unavailable energy also decreases. So when we are having huge amount of heat, okay, when we are having heat at a low temperature, it will have a large unavailable energy. For example, if I will give you 1,000 of joules of heat at say suppose 30 degrees Celsius. So what will you be able to do with that? Nothing. Why? Because the entire heat is at a dead state.
Yes.
So the amount of heat is very high, but it is at dead state because the entire heat is unavailable. Okay.
Yes, correct.
As we will start increasing the temperature of the heat, unavailable energy is going to decrease. Means available part is going to increase. And the available energy is actually a measure of the quality. The term actually we introduced in the thermodynamics to define the quality of energy. More is the available energy, more is the quality. Less is the available energy, less is the quality. And as the available energy is going to decrease, we can say that the quality of the heat is going to decrease. That's why that loss of available energy is also known as irreversibility. Fine?
Yes. Yes.
Loss of available energy is exergy destruction also, and it is having another name which is known as irreversibility. Fine,
Yes.
Shesh?
Yes, sir.
These things I asked you, so I'm happy overall with your performance. Molière chart, again, you need to revise. You missed some question. Okay.
Yes.
Interviewer can ask you some question related to pH diagram, TS diagram, PV diagram, HS diagram. These all are very important. Okay.
Yeah, okay.
So revise.
Sir, how do you express, like, what is the importance of Molière chart?
What we are getting, what we are, what we are having on x-axis and y-axis, enthalpy and entropy, na?
Entropy, yes.
So enthalpy gives us what kind of energy interaction is taking place in a process. So just by observing a horizontal line, we can observe the process is isenthalpic or what. Okay. Some kind of heat addition is taking place, rejection is taking place or what. Okay. Similarly, by observing the process on the y-axis, means if the process is like a straight line, we can say that the process is approaching some isentropic process. Okay. By observing that, we can say that more is the slope. We can say that much what you can say entropy change is there. Reversibility is taking place. Fine. So by just observing the lines on the HS diagram, we can say that the process is how much irreversible, or how the entropy change is taking place, or how much energy interaction is taking place. Fine.
Okay. Yes, sir. And so, what is the reason for that diverging pressure? Like, what I was supposed to do?
That also easily you can obtain because I asked you one question related to TDS equation. TDS equal to TH minus VDP. Okay.
Yes.
So if you want to draw the constant pressure line on HS diagram, DP will be 0. Change in pressure will be 0. So you will have equation TDS equal to DH.
DH. Yes.
Okay. So if you want to get the slope of constant pressure line on HS diagram, so DH by DS, okay, it will be what? It will be temperature only.
Temperature, yes.
So the slope of isobaric lines on HS diagram is nothing but the saturation temperature.
Okay.
So as the temperature of the substance is going to increase, the slope is going to increase. Fine.
Okay. Yes, sir.
That's why those isobaric lines, they will start diverging in the superheated region, because as when you are having some steam at some wet steam at some maybe low temperature. So the temperature is low, the slope will be low. So as the temperature is going to increase, the slope is going to increase.
Okay. Yes.
Fine. Clear?
Yes, sir. Yes, understood.
Okay. Good luck and keep revising. Okay.
Yes, sir.
Best of luck for your final interview.
Okay, sir. Thank you.